Welcome to another day, and today we want to look at one of the topics in elective maths that has to deal with vectors. Now, we want to develop a concept using these vectors, and the concept we want to portray using these vectors has to deal with a classroom that is characterized by what? Productive nuance. Now, before we start, you will attest to the fact that in everything we do, we always set goals or things we want to achieve at the end of whatever we normally do in life. And as part of these vectors, there are certain things we want to achieve at the end of our stage of the vectors. And that brings us to the objectives of what? The vectors. So look at objectives. One, by the end of whatever we are coming to discuss or to learn, we should be able to tell the meaning or explain the meaning of what a vector is. Explain the meaning of vectors. Again, we should also be able to look at how to represent vectors. Representation of vectors. Last but not the least, real life application of vectors. Like whatever which aspect of our dealings or our daily activities we apply vectors. We'll look at that as well. So real life application of what vectors. Of vectors. Alright. So to begin with, what are vectors? Any idea with what a vector is? Yes.
Vectors
Sit down.
are quantities that have both magnitude and direction.
He says that vectors are what quantities that has both magnitude and direction. Any other idea? Yes.
Vectors are quantities that have only magnitude.
Okay. Another one says vectors are quantities that has only what? Magnitude. Any other arguments? It means we have two people who are saying two different things. Which one do we take as the meaning of what? Vectors. Any other idea? Yes, myself.
It is a quantity that have both magnitude and direction.
Pardon? Louder.
Vectors are quantities that have both magnitude and direction.
Okay. She says vectors are quantities that also has what? Magnitude and direction. Alright. So we have two people saying vectors are what? Quantities that has both magnitude and direction. And another person saying what? Vectors are what? Quantities that has only magnitude. Now, in simple terms, vectors, we want to look at the meaning. Now, vectors are quantities that have both magnitude and direction. Quantities that have, they are that have both magnitude and direction. We want to look at examples of vectors. What are some of the examples of what vectors? Yes.
Weight.
Weight. Examples. Weight. Yes.
Velocity.
Velocity. Yes. Force. Okay. I think this are but few of the examples we want to look at. Then the next thing we want to look at is what we call scalar quantities. What are scalar quantities? Yes.
They are quantities that have only magnitude.
Now, I don't know whether you get the difference now. Someone now is referring to what scalars as what quantities that has only what magnitude without direction. But you initially made mention that vectors were quantities that have only what magnitude. But we came out to understand that for vectors they have both magnitude and what direction. Okay. So for scalars, they are quantities that has only what Magnitude without what? Direction. Examples of those are what? Yes. Distance. Okay. Examples. Distance. Any other? Speed. Okay. Thank you. Pressure. Okay. I think so. So these are examples of what the scalar quantities as well. Now the next thing we want to look at is vector notations. Vector notations. Now with the vector notations, we are just trying to look at how to represent them. How do the vectors will appear? Now under the vector notations, we usually represent vectors using what? The uppercase letters. For instance, if I have, let's say, vector AB with an arrow head on top of the two letters. The arrow head signifies the direction in which the vector will travel. For instance, if I have point A up to what point B. Now, if I happen to move from here up to my sister seated, it means I've moved from my starting point, wherever I'm standing now, to wherever she's seated. So it means if I happen to put it this way, it means it is just indicating the direction in which I undertook the traveling. So from A up to B. And that is how the vectors are usually what? Denoted. Any questions so far? Can we continue? Alright. So the next thing we want to look at is how to represent vectors. Representation of vectors. How do we represent vectors? Under this sub-heading, we want to look at how to represent vectors. And under here, we have two ways of representing the vectors. One has to deal with the column or component form. Slash column. Then we also have what we call the magnitude and direction form. And direction. Now, with the component form, if you have vectors, say that they appear in the form of A and B. Now, this A represents values on the what? X-axis, and the B represents values on what? The Y-axis, under the Cartesian plane. While with the magnitude and direction form, we are just looking at the vector, say that the vector appears with its magnitude, its distance, and that of the direction in which the star or it takes off with regards to what? The North Pole. Under the Cartesian plane, we have something we call the north, east, south, and west. Now, for vectors appearing in magnitude and direction form, it will always have what? Magnitude. For instance, if you have 3 kilometers, and that of the distance that vector travels with taking reference from the North Pole, let's say 60 degrees. So I'll represent it on a diagram and you see how it looks like. If you have, for instance, vector A, and there is the origin it says of. It travels up to what? This point B. Now the distance between the A up to the B is 4 kilometers. Now you now ask yourself, in terms of the direction, how it relates to the North Pole. From the North Pole up to the distance to travel from the A up to the B. Assuming here is 60 degrees. Now, if you pick the first quadrant, you recall under angles. In the first quadrant, the angle formed there is 90 degrees. So if here is 60 degrees, here we're left with what? 30 degrees. Thank you. It means that, but under here, we usually pick the magnitude in the direction of the vectors. We refer to what? The positive x-axis. So we'll look at the angle it forms with the positive x-axis. So here, which is what? 30. So we say that this vector is in the direction of vector AB, which is what? 4 kilometers. That is the distance it travels. And it has a direction of what? 30 degrees from what? The North Pole. And that is how we represent vectors under the magnitude and the direction form. Okay, we also want to look at negative vectors. Negative vectors / inverse. Now, if you have a vector, say that a vector travels from A up to B. It is in the direction of A, B, right? For instance, if I travel from here up to where you are seated, it means I started my journey from here up to where you are seated. I can equally move from wherever you are seated back to where I started. So if that happens, I'm now moving in the negative direction. And that brings us to the idea of what? The negative vector. So if I have vector AB, which is represented as xy. Now for E's inverse, it means that we will have what? BA, which will be negative. So this is usually also represented as minus x minus what? Y. And this is just the idea of what we call the inverse what? Vectors. Alright, now I want to look at the practical application of these vectors and our real life situations. Application of vectors in our So the first thing where in life we can apply these vectors is what? In terms of our travel. In terms of what? Travel. You realize that if you want to travel from one place to another, we usually use vehicles, for instance, cars or lorries. You see that if we move from maybe wherever we are here now, Bengal, if I want to move from here to what Yendi, it means we will have to take a car from here up to what? Yendi. And we have a direction in which we are going. For instance, if we are setting off from here up to Yendi, it means we have traveled from this place up to Yendi in a direction where we follow what? The route up to what? Yendi. You see that? So practically, this is where vectors are also what? Applied. You get that? Now also, in terms of what? Was it a scalar quantity or a vector quantity? It was a vector quantity. You see that? All right. So if you have any questions, you can ask. Any questions? Any questions? So if no questions practically or in a brief, that's what we wanted to look for today. Maybe hopefully in our next session we'll continue from wherever we have stopped. All right.